Hi guys, welcome to week 2 of COVID geometry. This week we're going to be looking at central angles and their arc. Yay! So we have a circle, we have points A and C on the perimeter of the circle, or the circumference of the circle, and B, believe it or not, is the center of the circle. Just remember, when I say something is somewhere, you have to believe me, I can't draw. Now, so I do actually have a central angle shown, and I have an arc shown. Here is that same angle, and this time you can see that we have angle ABC. Remember, the vertex is the middle number the middle variable that we use for the point. So angle ABC is 40 degrees, or approximately thereof. Now the angle cuts into our circle at point A and point C, creating the arc AC. And that also is going to end up with a measurement of 40 degrees. Every single central angle cuts into the circumference of the circle at the same amount of degrees as the angle is. So the angle of a central angle and the arc cut by that central angle are always going to be the same. Now on this one, if you notice, I actually added a third variable here, a third point on the circumference, point D. So to start with, we still have angle ABC is 40 degrees. We have angle AC is 40 degrees. But now we have arc ADC is 320 degrees. And how do I know that? I know that because a circle is always a total of 360 degrees. So if AC, so going from here around to here, covers 40 degrees, well, if I go the other way around, from A to D to C, well, that leaves 320 degrees left. Now the smaller of the two angles, of the two arcs, AC, we only has the beginning and the end point, and it is the one that is under 180 degrees, and it is called the minor arc, even though it is the more common one that we use. The one that goes around the outside, which is greater than 180 degrees, it's the one that comes around, and we need 3 points, a beginning point, a through point, and an end point. And that arc is going to be greater than 180 degrees, and it's going to be called the major arc. So we have a minor arc of less than 180. We have a major arc of more than 180. And we can also have semicircles of exactly 180. Don't see those very often, but they do exist. So we do have to keep in mind that circles are 360 degrees. And now to make math fun, we can throw some algebra into it. So if we have this same exact circle and arc AB is 40 degrees and the central angle is 5x degrees, how are we going to determine what x is equal to? Well, since we know that the central angle is equal to the minor arc that it cuts, we can set up the equation that 5x is equal to 40. Dividing both sides by 5, ending up with x is equal to 8. So I hope you guys learned something. I hope you guys do well this week, and everybody stay safe. Thank you.